sometimes you want to keep a torch because the stibnite, when it's falling through the bottom of the tube, it'll cool a bit and get plugged up, and you end up with stuff not working very well. So you don't have to keep a very big eye on it. It's not going to do any bad thing. But if it quits dropping stuff in the water for very long, you want to look at it.
This is it. Started. Once it started, it pours really fast. Especially this one, it's very pure.
Does anybody know why we're doing this?
Yeah.
So we'll have something to talk about, actually.
You made all this equipment.
What,
you want to keep it alive.
Here it comes.
Could somebody bring the bowl that had the stibnite in it?
Is all that stuff floating on the top there also from the antimony? What you don't want to do is
Yeah, you really don't.
smells like porcelain.
This is a nice ore stibnite. It's Bolivian. You can look at it if you handle it. Wash your hands. It's very crystalline, even though it doesn't look like a beautiful crystal. It has very little lead, very little arsenic, and it's almost the exact chemical proportions for a chemical stibnite from a chemist shop, but it's ore, so it's one of the finest. I'll show some other stibnites later. They're basically rocks that have some veins of this running through it. So if this is the best you can get, one reason to do something like this is to separate the semi-metal, this antimony sulfide, from the limestone or whatever kind of matrix it's in. Because if you just grind up something, this is a very pure one. If you have one half as pure, or a third or a quarter, how do you make a proportion, a recipe you could follow again for one? So this is a way of producing a standard from matrix. Why isn't it a problem to melt antimony? I mean, why doesn't it lose its life?
On all levels.
So it has a metallic life that stays here in level 10. So it's why it's used in metallic alchemy as an animating, a carrier of an animating principle. So this business goes on for a while, and you have, we'll see in a moment, you have pellets of stibnite that you can put in the scale and weigh them, so they're pellets. This one's blowing out more of this dusty stuff than I remembered. I'm not sure. Yeah, if we're pushing it up too high, maybe it's blowing apart before it melts. Makes these flowers grow funny colors. It has all the different planets in it. Maybe it scares the plants. I'll just show you what this is for. Gee, stuff comes out, doesn't it? And you have smoke coming out that you don't want to breathe. So if this starts following you around, move out of its way. If you see you have some different things. After a while, you'll get a very dense white smoke that's antimony oxide. It's very fine. It goes into your lungs very easily. It's toxic. When the stuff first begins to cook, if there's much arsenic, that comes off in the air, which is not useful. You have also just some chemical sulfur that burns. So any questions why we do this, and then after we can start to make the mixture. Which one? Huh? Ah. Yes. Just 2 holes drilled, so you can put a long screw through it to hold it, like this one has. Then you buy a box of about 10 saw blades that go in a power saw, and for about every 2 cuts you make, you use a new saw blade, and you add a new word to the vocabulary of your country. And so you make a series of cuts, maybe 10 or a dozen, and then you take a hammer and just start beating them down so they'll all come together like you're putting your fingertips together. So now you have a way that the antimony ore can fall out the hole. It's a simple solution, really. It's not. It doesn't have to look very nice. It just needs a hole in the bottom. Let's see if this one's plugged up.
So you just cut it and you hammered it? You didn't forge it or nothing, did you?
No.
Can you forge something like that?
I don't know. It was stainless tube. Just stainless pipe cut to length, and
what about the furnace? How do you do that one?
This one, Jean probably in a tin made. The inside is a bigger coil of, or a bigger piece of pipe tube that this hangs inside, and there's an air space, a little one between them. It's not very good. I think the temperature blew it apart, and she don't melt. So we do another one. Take all what you want.
You don't have anything one ready?
Oh, okay.
Another one of what?
You have one ready already.
Oh, in my lab I have already this material?
Yeah. No?
You find it? No, I don't have it. I don't think so. But Felix was asking about the heater. It's basically another tube, and there's some electrical insulation, then a resistance wire that we can show you coiled around it, then again some electrical insulation, and then thermal insulation. So there's just a barrier to keep you from getting shocked if you touch this, in a way. But the heat it's radiated heat pushed through the pipe radiated toward the middle, so there's not much distance. And this is filled with vermiculite, so this is just sheet metal, and after this material has electrical insulating properties, and maybe there's so much vermiculite, so that keeps the heat in a bit. Then there's a temperature control here.
Why couldn't you just heat that in a crucible and then pour it out?
You want it to fall out the bottom, and then they want an idea like a shot tower, where the metal stuff comes down and hits the water and makes nice little spherical stuff. You could,
But you probably couldn't fit it.
and you have to not pour the scoria. The scoria remain in the tube. We'll do another one in a minute, and we'll take it and beat the the junk will be left in here, and everything you want will have gone out the end. Sure, except
No, you don't want to look at
yeah.
it. Okay.
Yeah.
Well, there's
This
something-
is
Okay.
toxic on the outside. But that's, it's more open now. It's just
I
a
see.
spider's web.
Okay.
Russ, I have a question. You said you don't like the product that's coming out here. What is there about that you don't like?
That it's just stibnite that's not been melted.
I see. And then it just somehow went through?
What happens to moisture in the ore, the heat makes the ore fly apart. It's
see.
like popping corn.
So it flew apart and just ended up down there?
It flew apart without melting.
I see.
And what
Okay.
you expect a little blowing apart in the beginning, but you want to get the heat. Maybe we pushed a bit fast because we haven't used this in a while. After you get the temperature right, you just put in one, it works nice. You put in another and you have 2 tubes and you work all afternoon. The product's, it's nice stibnite, but it's just not been purified.
Can you reuse that if it were dried out? Could you
What you could do is sweep it up and put a little on the top, because when you load this, you put a big piece in the bottom to act as a valve. You put smaller and smaller pieces so you can always pour the dust.
dust at the top?
Yeah, you don't have to lose that. It's nice stibnite.
No. Okay. I just wondered. That's why I asked the question about what was wrong with it.
But the end product should be small balls. Is that what you want?
Yes. I'll see if I can find something that's like,
In that,
no. Nothing was, it didn't melt well.
yeah, it's nice concrete.
Okay, sounds like they're making some pieces to make the mixture with. Here. I can talk to you about some of the chemicals if you like. So you know the stibnite's one of the primary product. With the older formulas, you would use red tartar. It comes from wine casks. And it forms in layers over successive crystallizations in the wine. So it's like a little book with leaves in it. Sometimes you have larger crystals, smaller ones, but it's crystals out of the wine. The other product that was used is potassium nitrate or niter. Does anybody know what happens if you mix potassium nitrate and carbon and sulfur?
Yeah.
What
Okay.
happened?
Gunpowder.
Oh.
Dynamite.
This is antimony and what?
Carbon and
Sulfur.
sulfur.
Trisulfide.
And sulfur. Yes, so it's a lot of sulfur, in fact. This is potassium nitrate, and if you burn this, you get a nice, really black smoke, and the tartar is loaded with carbon. So you have a way to, the idea is to send antimony's life up the tree, but on a bad day you can send the crucible as high as this tree.
And
So-
life up the tree real
I was
fast
gonna
too,
say, your
but
life is
Yeah.
got control.
So the idea is not, it's possible to use tartar, but you have a better product in a way. It's easier to control with potassium sodium tartrate. And this is potassium, sodium, carbon, hydrogen, and oxygen, but it's not as likely to make a gunpowder. Sue yelled at me pretty bad one day because I had an explosion and painted the top of my head with burning chunks of stuff. And since she'd spent the afternoon saying, "You're going too fast, you're pushing this too far, you need to slow this down," I say, "It's all right." Boom! And I have molten stuff on my arms and on top of my head, and of course I can't say that it hurt or I'd be wrong.
Is that why you had to cut your hair?
So now I wear a hat.
Is that why you had to cut your hair? there?
No. But
You need it better than that?
this is iron metal. Jean was saying earlier it's not good to have iron dust, but this is actually iron filings that are rather coarse, so I think it's not too bad. Some of the old books, they used horseshoe nails that were the clippings from the ends of them and so on. You can use nails like this from the hardware store, and the thinner ones like a small wire. I have some smaller ones, but they rusted a little badly. So,
Iron nail, which right there.
yeah, or steel in this case. So, what chemically, what's the job?
Question, does it matter for the rusted or not?
I use ones that are not.
What?
The rusted ones I don't intend to use, but
No?
I think
Why would you use the rusted?
I think you don't want to, because the job of the iron wants the sulfur on the sulfide more than the antimony wants it. So if it already has oxygen blocking its pores, it couldn't take as much sulfur. So you want something, but there's an exchange. When the chemical sulfur of the iron, of the antimony moves, the alchemical sulfur moves. Some people say that there's a change, that one gives up sulfur and gives mercury, so there's something happening where there's an exchange between the iron and the antimony.
But it doesn't really matter if your nail has rust stains on it. It won't make a difference in it. So it's a matter of percentage.
By the time you're done, when it quits eating nails, it's done. So why don't you make a mixture?
Maybe?
Yes, please.
We should be taking, for stibnite, we should be taking, as we said earlier, if you don't necessarily have this Bolivian stuff that's very pure, you would use the dried product that would come out of this can there. Since we don't have it, we'll just make a mixture with this. I crushed it. I've been a bit lazy. I could have crushed it better. And this is why it's nice to have it coming out of this bucket, because it's going to be very small balls, like maybe 2 millimeters. And whereas here you get chunks that are still this big. We could crush them, of course. Just because of lack of time, we're just going to use this as is. Russ? Can somebody get me a spoon? I need a couple spoons here.
Spoon. Rusty needs a spoon.
And also, this probably takes graduation +5 to understand how it works, so. Oops. Ah, that's all right. Yeah, it is now.
Don't yell at me, man.
Ah. All right. How much do we want to put in there?
What's the formula in the paper? Anybody bring the paper?
120.
120, right.
Which formula are you reading?
Formula number
Number 2 or 3?
Number 2.
Formula number 2, right?
Right.
The one without the stock color.
Good.
You do not want to do what I'm doing here. This is really for the sake of the experiment, but we do not want those chunks, because when we make the mixture, we want the mixture to be as well mixed as possible.
Yes,
This is as close as I can. All right. This is half a gram, okay? I have 120.5 grams. The iron now, how much is that? 50 grams? Formula number 2 says 60. Does it?
Yeah, 60.
If you don't put 60, suppose you put 70 because you put too much and you can't retrieve it. What's going to happen?
That'd be, it won't,
The iron will dissolve.
it won't mix together.
Yeah, basically you lose in proportion. All right. Although this thing is sophisticated, I could just do 0 here, I think. Yeah. Now, when you do the purification, you use this. If you want to use iron dust like this, what I would do, I would use half iron dust and half nails. Okay, that's even better in proportion, because the dust will melt very fast, whereas the nails will need some time to be eaten. What's next?
What did you put in first? What was that?
Well,
what did you just put in?
Iron.
We're doing number 2?
Mm-hmm. What am I using now?
No.
Potassium sodium tartrate, 90 grams. Okay.
That one,
Yep.
the other one.
Which one are you?
The potassium nitrate.
And what I'm doing here also is not very clean. You're not supposed to do this. Right. This one here, yeah. So I put 60 grams of iron.
Can you take it out with a magnet?
Nah.
So the objective is to undershoot the iron and then make it up later with the nails, just so you just hit that right balance, so you don't over.
Exactly.
You get enough to
Well, right now we have overshot the iron, so we'll see what happens. Potassium sodium tartrate is how much? 90 grams. You never drop the spoon inside, otherwise you spoil the product. It may not be of importance if you're always going to use it for the same thing, but it's just a basic rule that you don't use it. We should have, like for instance here, then only I'll put it in there. Oops. Yes.
Doesn't that defeat the purpose?
Yes, well, do what I say, don't do what I do. Okay.
Actually, you got the spoon is clean now because he
Yeah.
cleaned the spoon with the product.
Okay.
Like the same thing when you dip in the jelly jar. After you lick the spoon, then you can.
And nitrate. 60.
And
Never.
raise your hand.
If you have put too much of the other products, it's not a big problem. With niter, you have to be very careful. It's better to put less than to add some more than the other way around.
What's the niter for? Is that acting just as a flux, or is that
Yes.
is that doing anything other than fluxing? Or?
It's a fluxing agent. Also, real niter, like the one you can scrape off the walls, has life in it.
The exterior walls of a building?
No, inside walls,
Inside walls?
caves and things like that.
Has what in it? Caves and old hotels, is that what you said?
Yeah. The one you're in now, I doubt there would be a...
Subway.
Don't they used to get niter out of outhouses?
Yes. Walls in the basement. Okay. Why don't you bring this to Russ now? First of all, here.
Want me to take the shirt off?
Yeah. What
Oh,
you do?
with the spoon, okay.
What you do? You don't do your mixture in this. You do it in a jar like this, and then you shake it thoroughly, so that everything will be mixed. Okay. Since we don't have it.
UPS.
Now delivery for you, sir. I got close enough for it. You gonna do it here or here? On passe pas tout à l'heure parce qu'il n'y a plus de gaz.
Ah,
Il y a de changer le gaz.
shoot.
On va attendre 10 minutes. Tu peux démarrer peut-être à ça?
Ouais.
Non? À Yuli. Non?
Before we went down here, I take some more gloves, do something else. And then like 2 people more.
Ouais. On peut le faire faire, il y a des gens qui le rejettent.
Hum.
Il y a Tim.
Mhm.
Je sais jamais son nom, c'est la bien. Non?
Comment? Non. Plus c'est avec du potassium, sodium tartrate, donc ça craint pas. Par contre, j'ai un problème au niveau de la boîte là.
Il a pas le micro.
Non, c'est moi qui l'ai. Oui, tiens.
Marcus, you can come in the car with me. Look at the hotel.
Made sense of what's the right, and there's not a pyrometer or something, so let's open the top and let's look what's inside. Okay, so it's not very quickly, you see you have a black messy stuff. You're making like iron sulfide and trying to free up antimony metal. So it's not a very, this one isn't exactly screaming along, so maybe we'll put a little more heat. Yeah, you cover it back up.
Did you wait till that stops smoking before you add more? Basically, so that the reaction
Yeah, the thing, yes, very subtle. So we'll add a bit more heat.
Reduction heat on this, that's why you have the lid on and all. You don't want to oxidize, you don't want to...
It does make a difference. You do the electrical furnaces they use, you can ask a 10. They notice the difference when they quit using the gas one and go into the electrical one. And it is the reducing, but I don't know. You'd explain, please. Actually,
The right temperature is when you see it. Once these furnaces have a temperature capacity of 650, 700 Celsius. Well, with the weather like this, it's okay, but when it's cold outside, they can hardly reach the temperature, the good temperature. So what happens is that you have to let it heat for maybe half an hour before you start working at it. Since we're kind of in a hurry, we're trying to do it, but it is not, the right temperature would mean that the walls are red around, okay? And right now they're not. They're starting to be, you see the dark red down there, but they have to be really creamy orange red.
And when the stuff that we're putting in, would it be melted down? And once
it will melt down. Once the smoke stops, what you do is you put another spoon, you wait for the smoke to come out, put another spoon, wait for the smoke to come out until you finish your load.
So you want to make sure when the smoke stops, most of the reactions settle down, and that's when you...
For the first time, you have to heat it really good because the walls are not warm enough. You know, it's like a balance. building up the seeds, right? So it does take some time.
That one looks very cold.
We can start the mercury distilling in between.
Because that's going to take a long time to actually get
yes. Il y en a des boules que Jean a montré ce matin.
Ah,
Balls of animated mercury in an amalgam. Yeah, they're already. It was an old one that John had, and he thought he might take it so that you guys could see it.
Okay.
There is a long process between this here and the balls animated here. We will try to describe it because when you reach this point, you're pretty much. Well, pretty much. No, you've already made an eagle. Once this will have flown, it will be an eagle. Okay. Depending on how many eagles John did before, it would be called eagle number 1, number 2, number 3, number 4, etc. Okay. I have no idea. Jean, tu avais déjà distillé ce machin? So it would be eagle number 1. 1. So, donc ce serait. It would be eagle number 2.
You just need enough heat to let this amalgamate, basically, or I mean, it doesn't seem to be a real hot.
This thing? Yeah. Well, I just started it right now. Okay. It's going to come red. You'll see it.
Oh,
it goes up to 300 Celsius.
And this is
350.
You said did you say that tube was?
This tube is quartz. We have made some.
Too.
Yes, yes. If you had to buy it right now, it would cost. Here, I don't know, but it would cost around $300 if you have to have it made because it reaches 1500 Celsius without moving.
Right, to get the tube in and
yeah.
the
But we've made some. I don't even know if this one is a quartz tube. Actually, I think it's just a regular glass tube. A regular glass tube like this might cost, I don't know, maybe $20.
Yeah.
cold water would get in the tube that's at maybe 360 Celsius, and it would just blow up.
How much is that Fahrenheit? A lot more, huh?
Yeah.
Fine.
Wait, voila. We have a little pipe. There was, here we are. This thing here is designed so that since here you won't get so much because we have only 2-3 of these little balls. So we scrape the walls and the mercury will gather and fall down. But especially when you don't have much like this, you want to retrieve as much as possible.
What's on the end there?
It's just foam.
Just foam?
Yeah.
So you can use to scrape the mercury out.
Yeah.
You brush it off.
You can see it here if you will come here and turn. First of all, you can see it. It's getting more and more on the tube, and you can see the mercury down there. See little balls of mercury? Mm-hmm. Maybe you want to see it from here.
Yep.
Okay. If in turn you'll come. Don't touch the.
Oh,
yeah.
on the tube.
On the tube, you see you can still see the couple down there, and there is mercury. I see the drops. Okay, they're very fine drops. Quoi? Ouais, je sais, je vois. C'est pas grave. John was just mentioning that there's condensation here too. Okay, it doesn't matter because eventually it will fall down, and the mercury will gather here.
Okay, so what we want is the mercury.
What we want is the mercury, and this mercury had already one eagle that John had done, and now it's having a second one. So you would have raised the energy level that it took from the antimony, would have raised it. Supposing you have taken maybe 25% with the first eagle, and the second will take it up to maybe 35%. It takes less and less each time, okay? And so 7 eagle will bring you to 100% of its potential.
That's when it's a double mercury?
Yes, and you don't do more than 7 of these eagles, 7. Okay, if you do more than 7, you may have accidents. Because you have accidents, explosions.
Now, are these the little tiny bubbles up there on top? Is that
Yeah,
what you're trying
that's mercury. When I'll retrieve them, you'll see it's like. I was watching Terminator 2 on TV yesterday evening. Okay, it's exactly the same principle. It's mercury. If you So what I'm going to do is wash off gently, and it's going to become a ball. You want to wash this thing afterwards in water.
What's the volume?
The volume? Oh, yeah, 500 grams of mercury. Yeah. But here we had maybe, I don't know, 20 grams, so it's...
Is there a preferred planetary or zodiacal timing for this operation?
No, but we have seen that there is a time where it's better to do this operation down there, which is when the sun, like today. No, when the sun is like today, when the sun is out.
Oh.
You get much better results. If you do it when the weather is overcast or the rainy, it doesn't give the same result.
So the sign of Leo would be a good time when you have a lot of sun and a solar sign?
What are you asking me if the good time would be when you have fire in the air?
Yeah.
Yeah, the answer would be yes. But the fire in Leo is already, the ancient alchemists used to say that it was already too dry and hot.
Too dry.
So if you wanted to really start the process in March, for instance,
okay.
Truly I don't think it matters except in January and December.
Nothing.
Because there's no energy. If you stay long enough around this thing, we may not have enough stuff in there. But I'm sure that it does affect, especially after the 3rd or the 4th, there is an emotional thing going on. And this I can't explain why.
But it's not
just
unlike you said, the distillation of your wine. By the 4th or 5th or 6th time over, you feel something going on between you and it.
Yeah, well, it's the same thing, except more powerful.
There's a vacuum being created here, right? So if the air is expanding, going down into the water?
Yeah.
Isn't there going to be too much of a vacuum that would cause it to collapse? How are we equalizing that?
No, when you heat, the air expands. Okay. In fact, there is exactly the same pressure outside and inside, because right now you see the tube here that comes out. there's only water, and the pressure pushes the water, and it's free up there, okay? So you have exactly the same amount of pressure, except that that's the law of Marriott, PV equals nRT. In other words, Irene,
yeah,
you're scaring the shit out of me. Sorry.
You bump it, Irene. That's what, you're in the danger zone.
Stay,
if you bump
stay away.
this thing could poison.
So at pressure, at constant pressure, or at constant volume, like here, the pressure is just depending on temperature. If you heat more, the pressure will push the gases out, but you have no more pressure in there.
But won't you eventually push all the gas out? Or you're not using that much heat?
You're not using that much heat, but even if you did, you're still under constant balance.
Yeah, the water will hold. If the water starts flying out, that tells you right there. There's your valve, right? Your visible valve is the water. So it's equilibrium, you know?
Yeah, it's balanced between outside and inside. There's maybe a little more pressure out inside now. Oh oui, non, il me demandait s'il y avait une pression énorme à l'intérieur, mais il n'y en a pas. C'est la même qu'à l'extérieur, puisqu'il y a de la...
What you're putting here is what we got out of there, right?
No. What you get out of there is a regulus.
Right.
It's going to take a long time before this regulus is ready to mix and to make a... It's going to take a lot of purification to make it a Marshall regulus. Once it's a Marshall regulus, you have to make a lunar Marshall regulus. In other words, for 50 grams of regulus, you will add 100 grams of silver, flux it again, and get a lunar Marshall regulus. Once you have this lunar Marshall regulus, you crush it in the mill. I hope that we can see a mill. We'll have to ask Russell to see his mill. And you add the mercury. Then you get this butter, this substance called an amalgam, but it's a butter substance. This thing you wash, and you put into balls, like, you know, butter is this substance that you can play with, like Play-Doh. Well, you make little balls like you've seen, and these little balls are in the cuckoo right now. But there is a process from there to here. It takes some time. So what you do is you fraction your work. First you prepare the stibnite, you prepare all your product. Then you're going to do the regulus, because you know you're going to need so much. Then you're going to do the amalgams. Once, you know, it's useless to do it once, then go back, etc., etc. You know that you're going to use so much regulus, and you know that you're going to recycle the silver that's in there. But you can at least make some good Marshall regulus and stock it. You can have like 2-3 kilos ahead of time, because you're always going to use it. You always need it fresh, because you take its energy, if you like, and it's going to be lost.
When do you know that you have finished one eagle? When do you know?
This now is, it takes 20-30 minutes.
But how do you know you finished? By when you have enough mercury, or?
Yes, usually that's the way it is, but within 20-30 minutes it's over. So you know, basically, and you'll see it.
And what about the balls? They're all...
well, they melted.
They melted?
So what you're going to have is a nice little cylinder ingot. Well, not cylindric, but spherical ingot in there, and it's got antimony and silver, and maybe some mercury traces, because you couldn't extract it all. This you will retrieve, burn it, retrieve the silver, pure, recycle it with Marshall regulus, do it again in there. So you raise both the silver and the mercury.
Okay, I follow you. What about the mercury that you are
that you retrieve? This mercury has 2 eagles now. One that John had made, one that we made now.
But the one that you retrieve...
No, no. What about?
What about the mercury? Are you going to combine it with the...
The mercury it's a second eagle mercury, and I will recombine it with a fresh lunar Marshall regulus.
Okay.
That I will use, and we'll retrieve the mercury with this. And this, so you'll have the mercury on one side, okay?
Yes,
the dead
and the water
doves of Diana, called that I put in the crucible exhale the fumes. Okay. I have silver. I have made some other regulus that I had.
Okay.
I crush the regulus with the silver again. Do another
small balls like
yes,
again.
like,
You put them here again.
Voila. And that's a third mercury and third eagle, fourth eagle, 5, 6, and 7.
Okay, I followed you all the way, but the only question I still haven't understood. What do you do with the mercury that you retrieve there?
It's the mercury. It's the liquid mercury. It's a mercury that has 2 eagles now.
But what do you do with it?
You put it aside. Put it aside.
That's what I was...
And then when you have your other lunar regulus, take this mercury, not new one. This one,
so
you recycle all the time. Otherwise, it would not have an eagle. Okay?
I see.
You're talking about the mercury that you clean off.
Yeah. You want to retrieve everything. You lose each time. That's why you start with like 500 grams. If you finish with 300, you're happy with it. Because you have losses during the whole process. Because the chemicals, I did it, like not so well. I mean, it should have been at half a gram. Sometimes there's 2 or 3 grams, etc., etc. Which doesn't matter for the first purification, but afterwards you want to be very careful. But there are losses. I got between 5 and 6% losses for every eagle. So in the end, you do end up with only 300 grams, 350. And you would make, and the mixture is something very personal. My personal figure is 3.2 in weight. 3.2 weight of mercury for the weight of lunar regulus. But a friend of mine used 3.10 and he was happy with it. We got exactly the same results. I do not know. Some people say 3. I have no idea of that. I think this is the personal equation there. But to tell you why I would lie, I don't know. I spent my time in Australia when I was a kid.
In where? In Australia?
Yeah. Three years.
How many?
3 years.
If you put these on a plate and let them sit out at night, they'll become wet. When we stirred the mixture with the iron rod, this is what stuck to the outside. It's mostly iron sulfide, so it's where the iron has taken the sulfur from the antimony. It's called scoria. So the first scoria are different than the scoria you get the second or third or fourth times. At the end, you have just a yellow, green, gooey stuff that it's not black like this. It's iron sulfide, mostly. But if you take these first ones and you save them and you put them outside at night, they become wet. If they become wet, they're useful. So you put them in a jar. But there's a way that you can take something useful from them. And you can ask John about it later. Exactly. The ancients called these things magnets. Like the salt of tartar is a magnet. You're a magnet. We're magnets for the stuff we need.
When you're done stirring it, have you tried stirring it with different things besides iron to see what it attracts out of it? The object iron actually becomes a filter.
I haven't tried. Let's add another spoon, someone. We'll see how it's doing. Why don't you pop the crucible lid? so we still have some junk. Okay. Now when he adds this, you want everybody to be able to stand back. Stop it. This goes back. Yeah, there's some iron that didn't mix well. But yes, sure. And it's probably better at the end to have a little extra niter anyway, in proportion.
What's the small ball there?
It's potassium nitrate. So that's what we're putting inside.
This is the what?
This is the antimony. The round balls are the potassium nitrate, and the white crystals that look like salt are the tartrate crystals. And the iron is more in the bottom, but it also is what adding the little rusty color. There's not much iron. There's some you can see now.
It's like more
Some
brown.
rusty color, yeah. There's quite a bit in here somewhere.
Would not melt after you roast it. Because you put the niter and all that, you will lowering it.
Yes, and also because the antimony admixture helps to make the iron melt more easily. The same as when you have regulus with silver. The regulus helps to make the silver melt more easily. Why, I don't know. Maybe we look and stir again. We'll take that one. Hey, why don't you open it? We'll stir a little. Just to push it down in. If we got a very violent reaction, we know not to add anything more. Let's add another spoon. So if you want to get a spoon ready. Okay, good. Right.
How long does it take usually? About an hour to do all this? Slowly, spoon by spoon?
It's been a few years, so I don't remember. But after the furnace gets hotter, I think so, yes. Yes, and also you begin to build a sense of rhythm. Now we have some inefficient use of time because we're not sensing exactly how quickly it's being consumed. And after, if you're doing it, you get to where you make the spoon the same and the time the same. I think when the rhythm is good, maybe roughly 2 minutes to a spoon. I think it says this in the paper, Jean's. So it can be quicker than we've done it.
This mixture isn't going to turn out the way it's supposed to be because we didn't use the antimony that was
There are two factors. One is the first one is never good. Or almost is never good because you're unsure of the temperature and the rhythm and things. The second thing is most stibnite wouldn't work very well because it has too many impurities and things, but this particular one is very, very good.
So that's why you're doing it with
Yes. We would have preferred to have had the other one that's more nodules so that you don't have big chunks and so on.
But so this way will work. Wait, okay.
I don't think the ancients did the purification this way at all. But when you have a research society that wants to make a very precise evaluation and say the formula is exactly this, you need to have a standard. And this is a way of making one that's repeatable, even with different ores of some way.
This is considered one of the shortest processes, correct? Of the short process.
The hard part is washing the amalgam. And so the process of flying the eagles and so on, it takes several repetitions of this, because when we do this we have a first regulus that we need to feed iron into and then purify it, and then we move it maybe with silver or something else. So yes, you have some time in this to make the powder and to make the amalgam and then to wash and distill. And every time you make an amalgam, you need new powder. I think we can look again. And the mixture is here. Okay. Let's put the cover back. Want to yeah, that's good. Yep, good. Useful.
Okay.
The later scoria are not very useful. These are useful.
So you can still throw that back in?
No. You could, from a lot of scoria, you can get more antimony again. But it's more useful for something else. When we make the regulus, you'll see something called the head of the crow. We'll cut the head off the crow. The sulfur goes to the scoria, yes, because the iron is there, and the scoria is mainly where the iron wanted the sulfur more than the antimony. It's more, it wants it more. But with the sulfur, chemical sulfur, also went some of the alchemical sulfur. So maybe it's why the scoria have something called the seed of gold. A little, the potential to become there is inside this. And the easy place to get it is from just use gold later. But not so cheap. It's hard to get the seed of gold purified from the scoria, but it can be done. You can get a red powder. It's a red sulfur that it's there. It's maybe not the best place to get it. Now I think we have more heat and we can put, again, let's look. See, before you add, let me yes, there's no new fires beginning or burning niter, so it's okay. Yeah, go ahead. And before you cover it, let's wait a moment. Okay. When you have, if we were to stir it and have something like this, you don't want to add more. It's a when you see anything like this, yes, no, don't add anything, because you risk a rapid
We're at the edge of the or not the board, but this one.
Yes, we're almost done. That's right. And they're hot. Now, yeah, very hard. No, c'est très chaud. It's très chaud. And now we'll begin to heat this up a little so that when we put the regulus inside, it's not cold. So, like so. Just, we have to be careful it doesn't fall in. It's good like that, yeah. I think we can, if you wanted to see if all that will pour in the spoon, we'll add it all in just a moment. Antimony is used in fireworks, yes. I think for white color flame. Sulfur, antimony oxide. So the white and the yellow. There's sulfur in the yellow. Antimony oxide, the white. Like the white on here is antimony oxide. Why don't you practice how to pour it? Let's say you have a form. You want to take the edge of the crucible like this and like that, right over the top. Or that you can practice, because if you get it the wrong way like this, it stays in, so you need to do something like this. Yeah. So you want to find a way that you can be sure you can take this thing and dump it into the container. That's how big the top of the container is. And the crucible's a bit delicate, so you don't want to bang it, but you may need to kind of jar it. But you'll just take it and pour everything into the the mold.
Yeah.
And then you, let's say you pour it, and then you're going to bang it like this. It's to vibrate to help make the layers separate a little. Pardon me? We'll put it here. We'll make another burn like that one, or like that one. Yes. Not very hot, not cold. Don't you open it and see? We'll stir. Pause it for a minute. Oh, it's sitting on a little concrete block made out of this kind of concrete. Because it's rocking, it's sitting level, and it's rocking back and forth, I think. So you'll see when he takes off the top, you have just a little space to get the thing. Putting it right there. Okay. So when you're ready, you tell Felix. You don't have to wear gloves. Not necessary. And dump completely everything, yes. Okay. Okay. Now begin to bang it with a hammer. You can set it, when it's empty, set it up on the side, not back down inside the, just set it up on the side there. And then put the top, yeah, good. And you put the top back on. Why don't you keep banging this, and somebody else can take the tongs and turn it a little once in a while so it's banged all around. Yes, thank you for your thinking. Yeah, you can just take it and here's the scraper. Yeah, and I'll try to find a something to scrape onto. It's easier? It's up to you. It's easier to set it on
Where do you want to put it? Metal there?
just as long as the stuff doesn't go on the ground, it's all right. Somebody else wants to bang a little bit on the other side, and then once in a while somebody turns the...
Going around the edge.
Good.
Actually, how clean am I supposed to get this inside?
Yeah. Just if you see any clumps, that you scrape them out. It won't be pretty looking, but there's a way you can chemically clean it out. Yes, in the very beginning.
Okay, well, if it shrinks small enough, it ought to come right out.
Maybe.
Yeah, we got a trio now.
Yeah. And then we get to the peg.
Okay. This is very in my neighborhood.
How long was that, Rod?
Well, the conductor lowers his baton.
The line goes, up line goes.
This line goes, huh?
Little turn for
Well, I'm going to get over there.
Yeah.
The Gandy dancers can get a...
Get a song going here.
Yeah, all right.
Reminds me of the shaman drumming session.
I'm doing the bass. Do, 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 do. Mi, 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 mi. Do, re, mi. I'm doing the E. I'm doing the E. That's me.
How long before you can pour it out, Russ? It looks like it's shrinking.
Yeah.
It's shrinking pretty well. You want to try to get it out?
Oh,
Not
yeah.
yet.
You want, if it is shrinking up, it won't be long. Yeah, I think it'll come out, actually.
So?
Yeah, let's put it where the most people can see it when it comes out.
See it.
On that
We'll
thing?
use this. This will be fine.
Okay, watch out.
You should come over on this side, and we'll bring a hammer in that. So just turn it upside down on there,
This thing is heavy.
and you'll need bang it out a bit.
There we go.
Oh, there you go. Now, put that away. Now, here's the good news. Looks like it's not such a bad one. We'll take a glove here. Now, with the hammer. You see there's silver around the edge
Yeah.
that's under there.
Yeah.
So that's the head of the crow. Is the black part.
Oh, there you. Oh.
Let's see that.
That's it. Good. Wow. You're standing away the camera. There it is. Wow.
Now,
Don't.
you can see there was there's stuff so the separation wasn't very perfect. There's antimony pieces here. So if you can always take this black scoria, break it up and remelt it, and the metal will sink to the bottom. You might put some niter with this to make it more fluid, so you could recover this.
And don't throw the scoria away.
The scoria are absolutely useful because when the chemical sulfur went to the iron, something else that's like a sulfur left the antimony to go there.
Should I have waited to do what you did, or should we do it while it's hot like that?
To break the stuff off? Yeah. Actually, I'm lazy because what should be happening is this should be coming off the sides too. It's easier while it's hot, so you do want to do it. And that's actually, it just got hit with a little piece. The black stuff is hot.
What's that stuff called? Regular.
It's yes.
Marco red.
it's not a complete ready Marshall Regulus because it hasn't been fed all of the iron that it'll take. As time goes.
No. What you mean do this again?
Oh, more than you'd like, maybe.
More than 6 and
Not more than 7.
No, wait. This thing here that you left in greenage, first of all, he's going to make several of these. Well, not now, but he would make a bunch.
He or she would. I would be a she.
Okay? Nicer. And redo the process. Heat, wait till they'll cluster, then put it in the still bowl. And then
put it in
start
what?
those
Okay.
Then put it
Important to get the graph on the
I think it's very important.
part of the flux.
Yeah. When I put it on the bottom here, it's breaking.
And the last time was just
Gloves are a blessing.
nice enough.
So I don't want to break it into pieces.
a certain level on the scale.
I don't think it has enough mass to do what I want. There we go.
What's the purpose of doing this?
It's
Your evolution. Right? On an invisible level.
Invisible level. Well, we're trying to...
there's still products to do from it.
Well, then it'll be easy to find.
On here.
Put your hand over it. Still be hot.
Camera. Yo!
Oh, you take
You're way of the camera.
But then, set that at the end, and you should also have to
Yes, the first time you were going to lose the nail, but the second time you're going to lose maybe 5 nails or 5
Oh, and
halves
they'll
of
be
nails.
left.
They'll be in the Scoria. You will see them in the Scoria.
Oh,
In the
okay.
black stuff, you will see the nails sticking out. And the first time, you have all your nails.
Oh, okay.
So-
So it's like a control.
So it's like a control that you have enough iron. But this is really nice for a first one with a furnace that was not that warm. Yeah, it's nice already. It doesn't mean that you don't have to purify it. You will. But for a first, sometimes the proportion is not wasn't so good because look.
Before we break it,
See what's left in the board?
Yes.
Well, if it was warm enough and the proportions were good, then you would not see this. You would have the written inside the no. But this for a first one is very good. Several of these, and then you will make several of these. The first one, because you're so you're not going to make one like this in suicide because you're going to lose a lot. Right. It doesn't matter scale. Okay. So knowing that you're going to need 500 grams of mercury and end up, you go from yen and end up and build it all you might need 2 kilos of fish. That means that you start with like 5 kills of fitness. If you work that way, I'm going to use half a kilo of mercury, 500 grams of mercury. So I'm going to use, suppose in my proportion is 3, I'm going to use 150 grams of each factory, which eagle, I'm going to use 150 grams of lunar resin. Meaning 50 grams of this and 100 grams of my silver, which I will always keep. And I need so many times to kilo is like 1,000 grams. And pound is like 2 something pounds. Also. 15, 20 pounds. Plus you're gonna make tests, you're gonna lose stuff. You need like maybe 20 or 30 of these for every day. Okay.
If you look on the top, this is the coolant.
different patterns. Maybe not unlike the insect, which is the books we're saying to look for. It has very shiny plates like this, the kind of radiant patterns. And this was bought commercially for about $1.87 a pound or something like that. Bought it, a box of it this big as a sample. So the antimony maybe does nice crystallization for things for people that work on it. But the weather, how the day is, how you are, what you're doing, what you're after. So there are things, the process is the main thing, of course. The purification steps as they're given is very good, very clear, it works. The crystallization seems to be the biggest variable. So the box Jean showed you where he says here are the signposts of crystallization is a very important thing. It's like rays anyway.
Like Russell says, it depends on Russell. Better not to work when the gas, but it won't work as well. First of all, you won't get as much. You won't yield as much. Second, the crystallization will not be fun.
We could weigh what we have there, plus this little piece, maybe in depth, just to see what it is roughly. You know, we lost a lot of it in here.
Is this actually a lot of leaves?
Finally.
Yeah, it's possible.
But you're going to lose it.
So we could weigh it just for the information. And then you try with the same, a different formula, maybe the same day, same furnace, same thing, so that you can see which formula works best with the ore you have.
This ore is as good as standard. Very little scoria. Maybe you've seen the food. But now, you will break this up into pieces.
Well, you don't have to. You can take it like this. You don't want to do it this way. Maybe what you want to do is like make it few of them, just leave a 10 of these, then purify. And you're talking this to because you're thinking of so many ecosystems. So in the end, you're going to need like 30 or 40 of these to start having some good regular society. Because you're going to be. There's a phrase in the Flamel.
For its business to have a lot. It is an old principle. Meaning, I've shown you a process for one, but for neither.
But we would mix it the same way as we did before, with the iron.
You don't need, at this point you need iron. For the second, you need vinegar. The formula is just to get rid of the sulfur.
Okay.
But then here you don't have to mix sulfur. Pretty nice, right?
I forget in the handout, was it marked what the second mixture was?
This one here. 120 and 59.
Yeah.
But since it wasn't pure scoria, because remember we used the oil, so probably that's why you didn't have such a nice fluxing scoria. Well, you've got some that's rock.
Okay, but
But it doesn't matter if you have the ore, you've already shared the purification.
Yeah, okay, we can clear that. Supposing now we have a whole bunch of this, now we have to purify the wood.
Yes.
You're going to take like, say, 4 of these, 5.
Fill up the crucible.
Fill up the crucible, fill up a clean crucible, or just straight and then put it back in there. And your furnace is still going.
By itself? Or do we mix some more?
You have to add iron.
Iron.
You can add either powder and nail, so just nail. It's up to you. After a while, you get used to it. You use powder and nail. Iron filing and flood some nitrate. Wait till it's fluxing. Pour it. That's the first purification. Do it again and again. And until the third time you do it, you put only nails. And you make sure that the nails come out in this. You will see the nails, they'll be sticking out. They didn't melt, so iron fusion temperature of iron 15, 3,000.
It's higher.
3,000. So if they're not melted, then you take this, which is a Marshall regular, you want to stir it one more time. You put it back in there with this nitron, and it's going to be a nice yellow crust. What you're going to retrieve is a big thing. This thing will be like, if you use 4 or 5, you're going to get a big one. Plus on top a nice green or yellowish crust.
I have done some maybe, but
this is the real Marshall regular. That's when you see the star. Yeah, you will see the star, and plus when you break it, you're certain that you will see the polarization, like the ones you saw in that painting. With this, you have on the book. You will mix like 50 grams of this with 100 grams of silver shot that you buy at the jeweler's shop or any wholesale shop that sells that kind of silver. It's no use purifying this gold. This is pure enough, but it's no use having silver ore at this point.
you can buy, here you could buy silver bars, silver bullion.
Yeah, we had shots, but if you guys have bars,
The bullion, the bars, the drops, pellets are nicer because you can measure it, and you can add as you need it. The bar is almost impossible to cut.
But what you would do, you would work the other way around. For instance, if the bar is 3 ounces, you would use 1.5 ounces of regular, because you can always crush the regular. But go and crush silver. Then once again, you put the silver and the very well purified, crystallized Marshall regular in the crucible, flux, let it in fusion with nitro on top. So you make sure that you never actually see the surface of the
That's always so much thing.
So much crust of nitro, because you're going to leave it for 10-15 minutes just in fusion, so that it gets main flux. This is the way you'll do it when the weather is. And once this is done, pour it, and you have a Marshall loop. Watch out, because you can lose a lot of regular, and the silver won't go. And then you have a silver, a silver bar or a silver ingot.
You can't break even with the hammer.
So you have to redo it.
So maybe you could use slightly less than the full amount of silver.
Exactly. The theoretical amount is 100 grams of silver for 50 grams of regular. You will discover that you will probably use 70 grams of regular for 100 grams of silver, because you lose some. The proportions are right, but you're just the fact that it's working makes you.
When you have white smoke, antimony is always going away.
Yeah.
We have a new coat.
I have a question about the process when you're adding the nail. If after the third time the nails haven't completely melted, can you do it a fourth time?
No. After the third time, the nails should not have completely.
Okay, when it has, if it has melted, I'm sorry, what's the word? After the third time, if they have melted,
Then we can do it a
a
fourth
fourth time.
time.
That was my point. I'm sorry.
Like Russell said, this is an equation. Depends on you, on the weather, on the quality of the product, on the purification you've been doing.
You do it as many times as it takes.
As many times as it takes. Usually in the books you'll see 6 months. But it may take 4, it may take them, it's up to you after a while.
Technical question. When you use the word infusion, everything's covered up anyway, or do you leave it exposed to sunlight at the end, or does it just everything penetrates through?
Oh, you just leave it closed.
Closed.
The lid plus this much of
Niter?
this much of niter on top,
On the top.
plus this on top.
Okay.
Plus this stuff.
So the infusion is between the elements that are in the crucible itself, plus the radiation, whatever.
Well, you know,
More
invisible.
invisible.
Can go, yeah.
It goes,
Can go through the planet
right,
without touching it.
right, everything else is invisible.
And maybe you're the biggest force field within.
We're maybe dealing with other influences. It's always nice to stick around because it's you working.
In fact, maybe if you need a nice day to work, that's your job too.
Yeah. Yeah, well, I bring my witch doctor.
Right. It's so simple. I have my assistant.
Yeah.
Just like you.
Shall we wait?
Yeah. Is that hot still or no? Here, we can drop it as well if you like. Why don't you take it up to
My name is Frank Paparazzi. Where do you store that? Patrice, any particular container? Just put it in a box or a glass test tube? Or when you store the...
When you store it in a
glass
tank.
Yeah. Do you want to pin this on?
Sure. This is where you gotta wait.
Finally it hurts.
The windbreaker.
So maybe somebody wants to weigh this? No. This is Russell's
Where do you want
You have
collection.
an empty jar, you can weigh the jar first and then calibrate it and put it in?
Yeah, sure. No, you don't want to. You just press on tar here.
No, I'm saying,
It's going to be calibrated.
can we put the jar on and then recalibrate it? And they only have to calibrate it once?
Isn't the water not supposed to be going anywhere?
Is it?
Yeah.
Where?
Yeah, I've seen it. If you look, there's a puddle.
No, that the water that was in there before and in the pellets.
Oh, okay.
It's all right though, because here it
Okay,
not so
yeah.
much, but it never got up here. There was some I saw it earlier. See, this trapped the water. The water will stay here.
Go to Great America. It's too dangerous. And I don't want to go home, Daddy. It's too much fun. Okay, calibrate.
Okay.
0.
Don't put the shit in it.
Oh, you want to... Just gonna weigh it.
53.8, let's say 54 grams.
That's about how much we have a segment?
No, we had 120 grams.
Oh,
okay. But we had stibnite. Stibnite is SB3S2. SB2, okay? SB2S3. So basically we've removed the sulfur from it. But the atomic mass of sulfur is not exactly the same as stibnite. So we have to make a calculation now. Do you have a... Yeah. It's not bad, huh?
How close is this?
It's done. Actually, I turned it off.
What if we people see what questions they have?
Yeah.
Have a break?
Yeah.
It's 10 till 4.
Yeah.
I think
Okay.
we're here at 5.
Yeah, okay.
So maybe
Well,
we
we've got
just
plenty
see-
of questions, I think.
Good. Why don't we
Yeah, but in the
say...
shade.
Yeah.
Plus.
Let's do that.
Yeah, okay. And you want to have somebody break this? What about Felix?
Yeah. You want to be the...
Felix, you
hammer
want
man?
I can break
What I'll do is... Yeah, there's a little anvil down there. In fact, yeah, cool. And
Don't,
we'll
like,
get
don't...
we'll get papers or something to
Yeah.
wrap it in for everybody to...
All right. Like how many pieces? Like 20 pieces?
Not so that everybody...
I don't want
think
one.
If you have 25 pieces,
Yeah.
and you'll have more pieces than you... What if we say a break for 10 minutes?
Yeah.
And then we start at 4?
Okay. Russell and I suggest that we have a break for 10 minutes and then we start, and we will see how we can go on with the process and answer your questions.